Good morning, good evening, everyone. It's good morning for some. We've got a presenter in Canada today, so I suppose I'm not too wrong. But good morning, good afternoon, good evening, wherever you are. A special welcome once again to this series of webinars. We are closing off today with a talk on the optimization of project portfolios. I hope you're going to find it exciting. It's the seventh and last one in our series, and we have covered a range of topics. It's been a roller coaster ride. I hope you found it exciting, and you will still refer to the content even when we are through with this series. I have introduced myself many times, and I'm not going to dwell too much on myself. The name is Prince Moyo, and I'm with both the South African Institute of Electrical Engineers and SAIEE. But for today, let me just remind you again that you can pose questions on the questions pane, and we will try and deal with as many questions as we can. Today we have one speaker, and he assures me he has got a nice and steady pace, and we should have enough time for interaction. I'm going to introduce the speaker that we have today, Boudwijn Neijens. He's with Copperleaf as Vice President for Marketing and Business Development since 2010. Joined as Vice President, but is now Chief Marketing Officer. He is also Chair of the Canadian chapter of the Institute of Asset Management, and he convenes various ISO and SAIEE committees and working groups on topics of asset management. He's got extensive experience in business development across the globe, Europe, Middle East, and Africa in particular, and in his previous life at CRIO. Most recently, he's been responsible for marketing, international business and product development at Aquatic Informatics. Boudwijn holds a degree in mechanical engineering from the University of Brussels, an MBA from INSEAD in France, and he's got these certifications here, CMRP, CRL, CAMA. So he's been tested and tried. He tells us in his spare time he's an avid sailor, and he's applying asset management principles to a fleet of vessels in British Columbia, there in Canada, helping to apply asset management principles at the same time being part of a worthy cause. So welcome, Boudwijn, and we look forward to your presentation today. I'm going to, with that introduction, I'm going to hand over to Boudwijn to take us through his slides.
Thank you, Prince. If you can, there you go. Let's see if I can switch over to the right presentation. You should now see my screen or my slides. Is that correct?
Yes, working perfectly.
All right, technology is with us today. Perfect. So thank you for the introduction, Prince. Always a pleasure to help out and to discuss these interesting topics of asset management. Actually, so far I've been listening in as much as I could to the series so far, and I've been really interested and really pleased with what I've heard so far. Both the quality and the content have been quite phenomenal. So today, in the last installment of this series, what we're going to talk about is the following. First of all, I'm going to quickly introduce to you Copperleaf, kind of recap a little bit of what we learned so far in the 6 prior installments of this series, which all are relevant to today's topic. Then we're going to go into asset life cycles and, by extension, economics, because of course it's always a balance between the technology and the engineering and the maintenance side of asset management and the finance and economic side. We're going to therefore touch on the concepts of CapEx, OpEx, TOTEX, how does it all works together, and how we go from long-term asset plans to budgetary cycles, and how do we actually get stuff approved and executed. That actually means that we're going to move from asset plans to what I call investment portfolios. You could call them project portfolios or whatever you want. Different organizations have different terminology. It actually forces us to think about value. As you know, assets are there to generate value for the organization, but that opens the fundamental question of what is value. So we'll talk about that. We'll actually turn that into a process, which we call asset investment planning and management. And then we'll finish off with a little bit of a technology dive into how prioritization of projects might compare to optimization, mathematical optimization of projects, and then draw some conclusions from there. So that's the agenda today. That'll keep us busy for the next 40 minutes or so, and then I hope that that will trigger questions on your side, and I'll do my best to answer. So very quickly, who's Copperleaf? So we are in the space of asset investment planning and management, sometimes called capital investment planning by organizations. And as you can see from the, some of the clients that you see here on screen, it is primarily aimed at utilities. And actually, even within utilities, I would say that presumably by now, transmission and distribution on the electrical side are the majority of our customers. You can see, no surprise, many of them in Canada, quite a few in the US. And then a smattering of people elsewhere. Europe is growing fast now. Australia, which is a hot spot in asset management, as I'm sure you know. Japan is actually starting to pick up quite nicely. And then we have one large client in South America right now, which is actually an oil and gas company. There's a few other ones in South America which are smaller and which are not on the screen here. And nothing in South Africa, so we need to fix that. But even without South Africa, we're already kind of managing about $1 trillion worth of assets worldwide through our systems. So that's starting to add up. And I think it does point to the fact that this is a very real problem that we're trying to solve here, and one which I'm sure you will recognize as we go about it. So enough about Copperleaf. Just to finish off, we're based in Canada. I'm actually based in Vancouver. It's morning here. And it's the day after Canada Day. So if I lose track of what's going on in my slides, that's just because yesterday was one big party. Of course, this was our national day. So what have we heard so far in the 6 prior installments, which, as I said, were all quite nice, quite excellent. First of all, we heard that we need a management system for asset management. It's not something that happens in a haphazard way. You need a management system in the same way that you would need a management system for safety within your organization, etc. Secondly, Graham kind of pointed out very rightly that a strategic asset management plan should be dynamic and express what's best for the company. And third, we heard about the fact that risk and levels of service really drive the way that we build our asset management plans and our life cycle plans. We, of course, heard that every organization is different. Very, very true. And of course, therefore, your mileage might vary. Tobogo reminded us that it's all about what, when, and if. And if is an important question in here, of course, like, will we actually do this or not? So we'll come back to that. He also reminded us of the fact that there's different reasons why we might want to invest and reinvest. And those compete amongst each other and amongst themselves. So it's a complex problem potentially. We heard that we definitely want to include both quantitative and qualitative factors in the evaluations and prioritizations of our projects and our decisions, which actually sometimes is complicated because especially qualitative stuff is often not easy to compare with quantitative stuff. Prince last week talked about the fact that projects that have the highest benefit cost ratio must be prioritized over others, which makes good sense, but how do we do that? And then finally, in a very early one, Rhys Davis, who is actually the chair of the ISO committee of ISO 55000, he kind of summed it all up and said, at the end of the day, what we need to do is you need to come up with a system and processes and a methodology where that's allow you to determine where you should invest your last 1,000 rands or your last $1,000 or whatever it happens to be. So where should you apply those to gain maximum value within your organization? So we'll try to answer those questions today. So if you look at it, there's a couple of key words that came out of that. Obviously, system, the fact that it has to be dynamic, the fact that it has to express what's best for the company, which is not easy to express at times, or to determine risk and level of service, key components, of course, the fact that there's differences everywhere. As I said, the what, when, and if was a great question. Economic cost, so it's a lot about economics. Finance and economics come in. Cost, of course, as a factor. Regulatory, which often kind of complicates matters significantly because the regulator might have different opinion as to what's important and what's not. The fact that strategy plays a big role. The fact that we're mixing quantitative and qualitative stuff. The fact that we need to prioritize, or even better, optimize, we'll come to that. The fact that we'll use ratios like benefit cost for that. And that is really your last rand 100 or 1,000 rand. In other words, at the limit, what should you be doing? Where do you put that last most precious money that you have? So those are really the things that we're going to focus on today. So I think the 6 previous installments were perfect kind of build up towards what we're talking about today. So if you think at it from a systemic point of view, this is a diagram that comes from the Institute of Asset Management, and in a way it sums up very nicely what it's all about. We're there to essentially come up with a model to optimize the value of our assets over its life cycle, over their life cycles, and that requires a number of inputs, of which we've heard quite a bit over the last few webinars. You need to analyze those inputs. That drives decision support outputs, which could be different options for different projects and scenarios under which you might want to kind of test your options. And that actually drives you to decision making. Now that decision making is effectively what we're trying to figure out today. There's like, what are the best decisions that we could possibly make? And of course, that decision making kind of feeds back into the loop, and we can keep rolling around. Now, very importantly, on this diagram, you have stakeholder consultation, which goes a long way towards responding to Graham's quest for what is the best for the organization. Well, that is very much driven by our stakeholders, as we will see as we move along. So, in other words, if you look at a life cycle of an asset, this is very kind of simplified, of course, but typically what we're going to do is at the beginning, we're going to acquire or create the asset, and that requires a decision, and we're going to spend big capex on that. Then we're going to operate it and, of course, maintain it over the course of its life. And at the end, we might want to dispose of it or refurbish it or replace it or whatever happens to be. That will require capex again. This is all cost, one way or the other. But of course, over the operating cycle, hopefully we're actually creating some value there. We're actually generating some money or some goodness. And of course, it's the area in blue there, which is the difference between what we're spending versus what we're making. That actually is what we're interested in. That's the additional value that we're bringing to the table. So value creation is what it's all about. Now, the life cycle itself could be anything, and we've heard different examples in the past. There is many different ones. This is just one example. I define a need, I plan for it, I design, I build, I operate, and then I dispose. But it could equally be a scenario where actually I can just buy the asset and then resell it at the end of its life. Or it could be that I kind of midlife.
Boudwijn, we may be having an audio problem.
Tell me what the problem is.
Just check that everything is okay on your side.
Can you hear me? Can you hear me?
Pardon me, gentlemen, but the audio has been perfect from my side.
Okay, so shall I assume that Prince is having a problem? I will continue, therefore, until you tell me to do otherwise. And of course, we could have very complex life cycles where the function of the asset continues and we're replacing it on a regular basis. So life cycle activities can have many different shapes and forms. And there is really two big categories that we can identify. The first one where we start from scratch. So we start in a greenfield world in which, of course, all my decisions are driven by future needs. We're essentially building something up from nothing, which is largely value-based, because what I'm trying to do is create future value. And the cost of not doing the project is essentially just a missed opportunity. I will not create the value, but there's no downside to it in a way, right? Like I'm just missing future opportunity. This is greenfield. Unfortunately, most of us don't live in this scenario. We live in a scenario in which we're in ongoing operations. where we inherit assets of the past, we inherit obligations of the past, and we just carry on. So the decisions here are, of course, driven by the existing assets to a large extent and their sustainment needs. And every once in a while we'll add or expand the system. So the decisions are, of course, still value-based, but also very much connected to risk, because the existing assets create a liability in the sense that if they misbehave or if they fail, hopefully not catastrophically, that is going to cost me. So the cost of not doing is a mix of missed opportunity into the future, but also the liability that we carry with us for our assets. And if we fail to maintain an asset, or if we neglect an asset, chances are that the asset will come back and bite us. So that is something that we have to take into consideration at all times when we build our asset management plans. And typically what we do, and we've heard about this in the past, and I think it was Petrus who actually kind of went into this in quite some detail, we will build asset management plans. And we typically do this per asset class, per asset type, where we really describe in quite some detail what activities, resources, timescales we're going to apply to that particular asset type. Often it's unfortunately a static view, as in I'm building a plan right now, and I'm projecting into the future what that plan might look like. If something comes and derails that plan, I need to start all over. In an ideal world, of course, you might try to make that plan as dynamic as possible, as mentioned by Graham, so that it kind of updates itself in an ideal world. These plans have a secondary aspect to it, and that is that they're generally speaking optimal per asset class. So in other words, every plan is perfect if you wish. But the question very quickly becomes, does perfection still exist when you add them all up together? And we'll come to that in a second. First question is therefore, what is the perfect AMP? So in other words, what is the ideal asset management plan for a particular asset class? And we don't know, of course. And you need to go about it literally by trial and error, I should say, where you're looking at the risk profile of that particular asset or asset type over time. And that risk profile, of course, is driven by the interventions that you have planned over the life of the asset. So at the very beginning, you might actually replace or invest in a new asset, and then you start maintaining it by kind of gradually kind of applying money every year to it, just from an operational point of view, a maintenance point of view. And then every once in a while, maybe you need to do a refurb that will reset the condition somewhat, and then you kind of work your way up the curve again, et cetera, et cetera. And this cycle, the exact shape of this cycle will of course be driven by a lot of the work that we've heard in prior sessions around reliability, around maintainability analysis, et cetera. The interesting part for me today is the big ones. So in other words, the exceptional items, if you wish, where we're going to need more money, and potentially therefore a kind of more stringent justification, and therefore, generally speaking, more stakeholders involved in those decisions. So they're essentially the decisions that will require more scrutiny and more work within the organization to actually allow for those particular activities to happen. Now, in order to determine when to do those particular activities, generally speaking, we go to economics and we look at a diagram like this. I know that Prince had a very similar diagram last week. We're not going to go into the details. The concepts are pretty well understood. That is, over time, you have your ongoing O&M costs. If you're looking for the ideal time to intervene on a particular asset as far as replacement or refurbishment, you're going to look at what is the cost of that intervention. And of course, the further you can defer that in time, generally speaking, the lower the cost will be in today's rands or today's dollars. On the other hand, the risk of the asset failing will increase over time, and actually at some point will start getting really running away, even if expressed in today's money. And therefore you can add all these together and you can find the total cost of the asset over time. And what you can find is that there is a minimum somewhere. And that minimum typically is referred to as the economic end of life of the asset. So if you can, and if nothing stands in the way, ideally that's the point in time in which you would intervene on that particular asset. If you do it earlier, you're essentially paying a premium for higher reliability. So you're effectively paying to reach a higher reliability target. If you wait, you're essentially going to pay a premium potentially to meet a cost target, but you're taking extra risk. So the question therefore becomes, are you more risk tolerant or less risk tolerant? Do you want higher or lower reliability? But fundamentally, if you're a pure economist, you would actually intervene in this case in 2022 on this particular asset. So you could apply this to every asset. You could apply this over the life cycle of the asset. So kind of resetting the curve and finding the different points on the curve. And that will get you a long way to come up with the perfect plan. Now, part of the perfect plan, of course, is to give the ability to your analysis, which could be manual or automatic, to consider different alternatives. And a few alternatives could be, in this case, as an example, if I have a misbehaving pump, I could just refurbish it. I could replace it like for like. I could upgrade it to a gold-plated, better quality pump. I could use the opportunity to increase capacity. I could use the opportunity to add redundancy. So there's different alternatives that I could be exploring. And of course, every one of those alternatives winds up with a different life cycle curve. So if it's a like for like, this is what it might look like. So, I might still need future refurbishments in time, and then at some point I'll have to do a replacement again. If I gold plate, I might actually require less work, both on the maintenance side and on the refurbishment side, and I can stretch the life cycle of the asset just because it's a better asset as a starting point. But of course, the replacement cost might be much higher because it's a better asset, a more expensive asset. And the question just becomes which one of these alternatives and many other ones actually gives me the overall lowest life cycle cost for a particular level of service or for a particular risk profile that I'm interested in achieving. So it's essentially a mix of different pots of money that I'm putting forward. I'm putting forward OPEX on an ongoing basis for operations and maintenance. I might have a blend of OPEX and CAPEX for refurbishments, and then I might have big CAPEX spend for replacement. But of course, what I'm interested in is in actually coming up with the lowest overall TOTEX over the life cycle of the asset, because that is really presumably the alternative or the option that at the end of the day will be most interesting for me as an organization. Assuming that OPEX and CAPEX, so operational money and capital expenditures, are equal from an accounting and from a regulatory point of view. Many of you, since you're working in the electrical sector, might be subject to economic regulation. And in some countries, economic regulation actually favors CAPEX. So in other words, you get a fixed rate of return on the CAPEX that you spend, which often incents you to actually spend more on CAPEX and less on OPEX. And then you might wind up with a curve like this, where you're actually doing minimal maintenance and you try to replace the assets as quickly as possible. The asset manager has to understand this because it might actually drive his behavior. Even if it's not a rational behavior from an economics point of view, it is a rational behavior from the company's point of view because the rate of return is guaranteed on CAPEX. Whereas in other scenarios, you might actually be starved for CAPEX. Maybe it's difficult for you as an organization to raise capital, in which case the mandate might be just put more money into OPEX, spend more on maintenance, refurbish as often as you can, and try to stretch the life cycle of the asset as long as you can until we are in a position to raise CAPEX again. So these are extraneous factors, which of course you have to understand because they might affect the way you're making decisions in asset management, or they might affect basically how OPEX and CAPEX compare in the context of coming up with a TOTEX answer. Now, this all adds up into what Graham presented in webinar number 2, which is a strategic asset management plan, which is effectively the roll-up of all your AMPs, if you wish, or to put it the other way around, it's the guidance that you're going to be using to develop all your AMPs within the organization. This is a key concept, and hopefully in your organization, the SAMP actually holds water. And the reason I'm saying that is because very often what we do is we develop asset management plans per asset class, and we of course develop them in such a way that they're optimal for every single class in isolation. Why? Well, because it's different teams looking at their own assets that come up with these AMPs, and they're all optimal. They've sweated on it and they've come up with the best plan for every one of them. The question is, does it all add up? If you actually add up all your AMPs, can you actually afford that? both from a money point of view, from a resource point of view. Does it actually achieve the overall organizational goals from a point of view of level of service, risk reduction, etc.? This is a very difficult question, and actually often one where the rubber hits the road, in the sense that challenges do appear in organizations when this roll-up happens, which in a way often is the problem at the C-level of the organization. It's the CEO, the CTO, which all of a sudden discovers that all these optimal plans don't add up. And they don't add up because there's not enough money for everything, there's not enough people for everything, there's maybe not enough time to do everything, or the risk targets might not be achieved. So this is really where the fun starts. And one way of looking at this is to actually kind of make it a bit more immediate. If you have a SAMP which covers maybe 20 years, for argument's sake, generally speaking, where the rubber hits the road is in the first 1 or 2 years, at the very beginning here of the diagram, because that's of course the vertical cut that we're going to take across all the plans and add them up for next year's budget, say, and say, well, sorry guys, but you're asking for too much money, so somebody's going to have to give. And this is of course a problem which brings us into what I call investment portfolios, where this vertical cut that you take from your asset plan is the portfolio of all the activities that you'd like to achieve in the next year, or maybe in the next 3 years, depending on the organization. And that needs to hold water. That needs to be something that you can actually take to the bank, and that you can get financed, literally. The bank might be internal, of course. So when you think of it, if you have this massive portfolio of all the good things that you'd like to do, you have many, many constraints around that. You have, of course, financial constraints. You also have total risk targets. You do not want to go above a certain level of total risk within your organization. You have resource constraints. You might have outage constraints of how many circuits you can take out of service at the same time. You might have other targets, renewables, for instance, asset replacement targets, which are set by the regulator, etc., etc. So you can take one of them and you can kind of apply a constraint to that, and that might push out some work. But unfortunately, if you take another one, risk tolerance, for instance, that might actually favor different projects, because some projects, kind of deliver a higher risk mitigation, and therefore they will be favored under this particular metric. Resources, as in people, you might have multiple constraints there. You might have a maximum, as in there's only so much work we can do with the people that we have, and only so much overtime we can squeeze out of them. But equally, you don't want people to sit idle. So there's also a minimum constraint there. Is like at any point in time, we should have enough work for at least, say something, 80% of the available human resources, etc., etc. So you can apply all these constraints in parallel to the same portfolio of projects which is in competition, and you wind up with a holy spaghetti of different constraints, which from a mathematical point of view make it extremely difficult, certainly in a spreadsheet or in your head, to come up with what is the optimal answer. What is the answer that delivers the highest value to the organization while I'm honoring all these constraints and all these objectives, strategic objectives that I have within my organization. And this is effectively what we're trying to solve today. That is, how do we come up with the highest value, honoring all constraints, and doing it in such a way that I can guarantee to both my CEO, my CFO, and the regulator that this is actually the optimal answer. Now, that is the key reason why earlier on I said that a few key words had been mentioned in previous webinars, and in particular the fact that our AMPs and ideally our SAMP should be dynamic, as in they should understand time, because sadly enough, not only is the problem complex, as we just saw, but also the world moves on. And initially, when I wrote my SAMPs and my AMP, I might have come up with a great plan, but there might be reasons to revise a particular plan or a particular asset project. Maybe parts are late. There might be stuff that needs to be deferred for whatever reason. There might be new projects which are being added, which we hadn't really planned for. Maybe the regulator told us there's a new safety regulation, and all of a sudden there's a whole bunch of projects that we have to add. So the only way to manage this, of course, is in such a way that we can very quickly adapt our SAMP, our AMPs, our business cases, and that we can dynamically see what happens if the world changes on us. And needless to say, the last few months have proven very clearly that the world can change very quickly on us, and that we have to be very agile in rethinking our decisions and stay optimal as best we can in this interconnected kind of portfolio that we're building here. The process that we use for that, once my little scroll wants to move on there, is therefore what I call the asset investment planning and management. And what we do here is we look at our existing assets, and our existing assets have needs, like they need to be maintained, they need to be sustained over time. They might even every once in a while fail and create emergent work, where immediately we have to intervene. So our assets have needs. This is why asset management is such an interesting challenge, as we have to stay on top of our assets at all times. And those needs translate into what I call here candidate investments, candidate projects, candidate programs, things that we would like to do. Maybe in the next 2-3 years. So these are very immediate and well-defined needs. And they compete, of course, with other needs for resources. So in other words, if we have to expand our network, if we have to expand our business, if there's new technology that we have to bring in, if there is possibly even assets that are obsolete that need to be swapped out because they're unmaintainable by now. So there's other business needs which kind of interface with the asset needs. And the portfolio is often therefore a mix of sustainment and expansion or growth or new business projects. We need therefore some way of assessing the value of all these different projects and investments that are in competition. We need to be able to evaluate them on a common scale so that I can actually make sense as to what is the relative merit of these projects compared to each other. If I have them on a common scale, I put them in literal mathematical competition, in the sense that I can actually throw them on an optimization engine. That optimization engine will look at all the projects at their value, rank them, of course, by value as a starting point, but then start playing games. In other words, it will look at every project and say, okay, well, if I were to move this project out by 1 year, how much would the value, the cost, the risk change, and am I better off or not? In the same way, it might look at different alternatives. If I had 2 or 3 alternatives that I looked at for every project, I say, like, well, how about I move off the preferred alternative to another alternative for this particular project? How does that improve my overall portfolio? Does that allow me to do more work elsewhere which has higher value or not? So optimization is essentially a massive trial and error exercise that you go through in a mathematical way to actually come up with the best combination of what to do when, to actually generate the highest possible value for the organization and honor all the constraints, financial constraints, human resource, timing, etc. So out of that comes an investment plan, which might be 3 years or 5 years or whatever it is, typically the window in which projects will be executed. That plan, once you're comfortable that it is actually robust, well, you will take it to management, hopefully it'll get approved, so it's get budgeted therefore, and then you start executing. Whilst you're executing your projects, things will go sideways. There might be cost overruns, there might be delays, there might be projects that finish early. There might be external factors. Right now, the pandemic, of course, is throwing a massive spanner into a lot of our work. So that requires operating updates. And if those updates become too variant, in the sense that there's too much of a deviation from the original plan, presumably what you should do really is hit the brakes for a second and say, guys, let's look at the new reality, let's re-optimize our portfolio and see which projects we should now favor in light of the new reality. And that might need reapproval by management. So this kind of closed loop here on the right hand side is what we call performance management. And it's something which typically organizations from a capital planning point of view would do on a monthly, on a quarterly basis, just to make sure that within the execution phase, you stay optimal. Because unfortunately, in many organizations, that is only done as a post-mortem at the end of the budgetary cycle, at which point it's too late. You've wasted a budgetary cycle and you've come to the conclusion that you've only done 70% of the work. Well, it's too late now, you're not going to catch up. So you want to do this at a frequency of monthly or quarterly or something like that, and then you have a chance to basically adjust as things are happening. At the very other end of the scale, our assets, of course, as we all know, have their own life. They typically degrade over time, and ideally you want to predict that degradation. So you want to have a model that actually tells you for every asset type, even for individual assets, if they're really critical, how will this asset evolve over time? That is a prediction. And that prediction allows me to basically go and build my life cycle strategy, as we saw earlier, by kind of predicting into the future when ideally would I want to intervene on this asset in a major and possibly in minor ways. This is very important because if I have these good predictions, which are the foundation of my AMP, if I can feed all this to the financial community within my organization, I can show them how the future looks. I can show them that in 5 years, 10 years, 15 years, I'm going to have a big bump of investment coming at me. So it's one of two. Either the CFO goes shopping for money so that when we hit that bump, we're ready for it. We have the money and the people to actually address it, or we actually smooth the curve in the years to come. So we actually do some work a bit earlier, some work a bit later to actually kind of smooth out that bump. But the only way of doing that is actually knowing that it's coming. So you do need some predictive ability to actually allow you to see those bumps coming and to work towards them. A secondary effect is that, of course, it also means that these same models that predict when the bumps will be can also be used in the optimization engine. So if the optimization engine says, hey, what if I take this project and I move it out 2 years just to see, how that would affect the overall value of my portfolio, the risk of the underlying assets will continue to grow during those 2 years. Like if I'm replacing assets and I've just decided not to replace them for 2 extra years, that's 2 extra years of risk, potentially higher risk that I'm carrying. So the same models will be used to actually allow the optimization engine to recalculate the risk to which I'm exposing the organization if I were to defer projects in the process of coming up with my optimized portfolio. So it's a closed loop environment in which we operate. And it really is a blend of what we engineers and asset managers tend to think of, which is the bottom-up approach, where we know our assets, we look at the data about, around their assets, we look at the models, or we try to model our assets, and we come up with a prediction of what our asset is going to do into the future. And that actually justifies our spend, or at least our request for spending over time. Management tends to look at the top-down view. They see all these requests coming in, and their natural reaction is, gentlemen, this is too much. So in other words, there's constraints. Sorry, there is constraints, financial, resource, etc., that we have to apply to all your requests, and hence the need for optimization, so that from a top-down point of view, I come up with an answer which actually holds water and that I can sell to management, and that is actually executable because we have the money and we have the people to actually do it. So this is asset investment planning in a nutshell. It's a process which is applied more and more, specifically in the context of utilities and the electrical industry in particular, for the good reason that all three of the concepts you see here are equally important and need a cohesive approach across everything. Now, central to all this is the word value. We need to assess the value of every single one of those projects that we're evaluating. So we need to understand what value is. And that is a tough question because it very much depends on who you ask. Even within your organization, if you ask, okay, well, according to ISO, my assets are here to generate value for the organization. What is your definition of value? You might wind up with very different answers depending on who you ask. On the maintenance side, the engineer might say, well, that just means a very reliable asset. The accountant might say, well, it just means let's kind of spend less and make more. The shareholder might have a broader view of that. Operations might just look after efficiencies, etc. This is internal. You could play the same game externally and get even a broader perspective, of course, of what value might be. And as an example, I'm using a very simple example here. If I have a car, what's the value of a car? Well, you could kind of come up with a list of potential candidates there, right? Like it should be affordable, should have good looks, good speed, safe car, etc., etc. You could come up with your own list. If you ask your spouse or if you ask your insurer, he might have a different view. So you might have either different weights or different elements altogether. Now, if I look at the car from a project point of view, if I want to replace this car, the obvious answer is let's replace it like for like with this year's model. But I could also say, well, no, as alternatives, I might either refurbish the car or I might upgrade the car whilst I'm at it. Or I could go one step back and say, well, the problem is actually not the car. The problem is I need to get from A to B. So I know I could use shared cars, I could use a limo service, or I could use the bus. And every one of them has a score for every single one of those value elements. The trick, of course, is to come up with a way to normalize those scores in such a way that I can add them up and that I can come up with a total score, value score for the different alternatives. And in this case, maybe the best alternative indeed is to replace the car. But that assumes that the 6 elements that I have here have a relatively equal weight. If I now come to the conclusion that I'm driving the car alone 99% of the time, maybe space doesn't carry the same weight for me. I don't need all that space. And then maybe all of a sudden transit becomes the better option. Of course, right now to take transit, you also have to invest in a face mask, but you know, in normal times, that might be the case. So you can see the concept here, and in an organization, you're going to apply the exact same concept, of course, at a more rigorous scale, and you know, you'll do your homework, consultation with internal and external stakeholders as to what the value elements are, how do they align with your strategic objectives, and how do I actually express them in such a way that I can add them up. So this is quite a bit of work, but it is absolutely feasible. And this is what we see here. That is, at an organizational level, you might have your big strategic objectives. And then, of course, we have to align our asset management objectives with these strategic objectives. But more importantly, we have to quantify them. So the exercise we go through is we actually go into organizations and say, okay, what are the measures that you can use within your organization to actually specifically quantify how you're moving the levers of, for instance, reliability service. So in other words, you know, black start delay risk, you know, how does that play into reliability service? How do you quantify that risk, et cetera, et cetera. This is just a fictitious example that we're seeing here. But this is very real. This is exactly the way we do it. We build what we call a value framework in which, you know, you kind of start by identifying the strategic objectives, and then you translate that into stuff that is measurable, because you can only manage what you can measure. And then those are the levers that you can actually pull. So if I'm creating a business case, that business case should at the very least kind of improve or move one of those levers, ideally more, so that I can build up a business case by essentially adding up the scores of value improvement or risk reduction that I generate by doing this particular project. Now, risk and value are obviously therefore very well tied in together. If you think of risk as something that increases one way or the other over time for a particular asset, that will be your baseline. At some point, you're going to decide, okay, that's enough. I'm going to intervene, and therefore I'm going to reset the risk curve. The outcome of my intervention is basically a lower risk curve. What's the benefit of doing this? Well, obviously the benefit of doing this is the area in between the two curves here, which I could translate into value. That will be the accumulated value of doing that intervention. I can then actually net present value that back to a value today, to me. And you see a dollar sign there. Increasingly, what we're seeing is organizations actually do monetize all their value, both on the risk side and on the positive side. So additional value, as in, you know, increased customer satisfaction or whatever the elements might be. Everything is monetized simply because that, of course, makes the math much simpler and much more rational. I'm spending money to actually create value, which I can also express in dollars or in rand. Which means that we have to align all these metrics. We have to come up with a way of defining that, you know, if I say that a particular metric is negligible, what does that mean? And a table like this you might have seen in real life. This is on the risk side, but you could do the same thing on the value creation side, where you're essentially trying to define for your risk matrix how these different elements would compare. So if I say a negligible safety risk, that's an on-site first aid injury, so virtually nothing. Financially, that means I'm losing less than 100K, maybe in lost generation or in lost distribution. You know, that means maybe a TX frequency of outages in my network of less than 17 per year, whatever. And you can see how we normalize everything. In doing so, implicitly, you're attaching a financial value to everything, because it essentially means that an extreme risk, an extreme safety risk is equivalent to a risk of over $10 million in this case, or rand. So implicitly, we're kind of applying a financial cost to everything, and or a value to everything, and that's what we're seeing increasingly organizations do. Some actually have a internal currency, so they don't use rand. They use some internal currency just to kind of dissociate it from real money. But the exercise is exactly the same. You have to normalize everything so that you can come up with a way of comparing things. So the process is as follows. First, you have to identify what are the criteria that deliver the greatest value to the organization? So the metrics that we talked about at the very beginning there. Then you have to align those metrics, which we just went through. Then you can apply those metrics to assess every single intervention, every single project that you have in mind. And then you put them in competition to actually optimize your portfolio and to actually kind of ensure that your portfolio will be basically optimal from a value point of view and also from honoring your constraints. Now, optimization in its own right, from a mathematical point of view, is just a bit of heavy math. The most known algorithm that we use for optimization is the simplex algorithm, invented something 80 years ago. It's just a simple way of quickly iterating to the highest possible value under multiple constraints. So it's a multi-criteria decision analysis tool that allows you to quickly come to the optimal solution in a complex problem, which therefore requires a fair bit of computing power. But today, computing power, as you know, is cheap. What it really does is, if you compare prioritization to optimization, if you have here the same portfolios of projects on both sides of the fence, if I were to prioritize this, I might look at this and say, okay, well, first thing I'm going to do is I am going to consider only the projects that I'm going to do this year, because that's as far as my brain can go. The second thing I'm going to do is actually rank them by value. So the highest value or highest score projects I'll do first. Then I'm going to apply a constraint. I'm going to say, sorry, I only have $10. So, I'm going to put a cut line there, because beyond that, I'm spending more than $10, so I cannot do that. If I'm really smart, I could say, whoa, hold on a second. Project number 5 there is $1. That actually fits in my $10 budget. So if I move those projects around, I can actually do one more project and create a little bit more value. So now I've achieved a value of $250 out of a possible of 300 in this first year, just by kind of doing a bit of shuffling, which I could do in a spreadsheet quite easily. On the optimization side, what I do is I'm going to essentially just press the button, and the system will automatically start by deferring and advancing projects, because it can actually deal with time sensitivities. And then it might actually go and consider different alternatives or different options for projects. And with that, it will wind up with a answer which could be totally random. Like there's no way of immediately seeing what the answer is going to be, but as you can see, the value that can extract out of the portfolio is $325, spending only $10. So generally speaking, this is very consistent with what we see in real life. That is, an optimization, a mathematical optimization, will actually achieve much better results than what you could do in a spreadsheet and by shuffling a few things around in a traditional prioritization. Now, one aspect which we talked about is time. The good thing with time is the further away the event, the less it matters today, because you're essentially kind of discounting for the uncertainty into the future. It does mean that there is uncertainty in the future, and right now, of course, with COVID, there is a lot of uncertainty in the future. So that actually forces us to explore multiple scenarios. Like, what if the future looks different? What if there's less money? What if there is more growth? What if a regulator changes something? So there's many scenarios that we should explore. Again, that's a lot of work. And that's one of the reasons why typically you would want to automate this, or you would actually have want to have a system that does these calculations for you, so that you can actually multiply the amount of scenarios that you can explore. And then you can start comparing. You can start comparing how, in this case, for instance, a couple of different risks and costs would evolve based on different scenarios into the future, and which one actually feels most comfortable to you. It drives us to a mathematical concept which is called the efficient frontier, in which if I'm going to move, let's say, the amount of money that I spend. So the what if question right now is, what if the budget gets cut? If I move and try different scenarios, then I'm going to discover that I'm going to achieve different levels of value based on different scenarios. And after a while, what I'll discover, if I iterate enough, is that there are some points which seem to be as good as it gets. So in other words, there is an efficient frontier here. I cannot go above that efficient frontier. I cannot, by spending more, I cannot generate a higher value. And looking at this, it actually flattens out after a while. So spending a lot more is going to give me nothing. So maybe this is my inflection point, or maybe even here, that's my bang for the buck is still pretty good. Beyond that, it's getting less and less. The problem is, I don't know where that efficient frontier is. I don't know if it's here. I don't know if it's there. The only way of achieving that or finding it is to actually do what-if iterations on your portfolios, so that the system, by mathematical optimization, will find this efficient frontier for you. And now that you know it, you can actually take it to management and say, okay, gentlemen, what I propose is, let's spend this. And if the question comes back like, yeah, well, what if I give you 10% less? You can immediately say, well, then this is what we're going to see as the best possible outcome. So it arms you with a very strong argument in your discussions. It ties in, of course, to the cost of not doing. Your assets will over time misbehave, and you essentially have to spend money to avoid that. So it's this virtuous circle that you have at all times. And you can translate that into a graph where if you save money, so essentially if you're cutting out of your budget by saving more and more, the risk exposed in the organization will increase too. And at some point, maybe around here, there's going to be an inflection point at which the risk starts running away from the savings. And that will be the absolute maximum that you would want to save, because beyond that, your risk is effectively out of control, if you wish, within the organization. So this is a very real graph that a lot of our customers use to especially talk to the regulators. So conclusions. All the previous speakers were right. I think every one of them brought a good element to the table on which I could build, which was wonderful and very nice from them. Engineers and technicians tend to think bottom up. We tend to think from the assets upwards, which is totally natural because we care about our assets, whereas management tends to think top down. They look at the constraints, they look at the objectives of the organization and push from there. So it's a matter of combining both. And therefore decisions need to consider both all objectives, constraints, and of course the needs of the assets. Sadly, everything changes with time, which complicates the issue. In an ideal world, you want everything to be dynamic, as Graham said many webinars ago. Prioritization, generally speaking, leaves money on the table, as we saw in that little example. And therefore, you want to kind of start looking into techniques like multi-criteria decision analysis, which is a very generic technique which has been used in other industries for a long, long time. And we can apply it quite easily to asset management. And in asset management, what it would mean is you want to consider alternatives to your projects as a way of doing your due diligence, really. Make everything time dependent if at all possible. Develop a common value scale, so basically the value framework that we talked about, and ideally monetize it. Use a proper optimization system to actually kind of find the better value for you. Explore multiple what-if scenarios, especially now in these uncertain times, and close the loop. So in other words, kind of do your performance management and your long-term planning in a cohesive way so that all your decisions are coherent and that changing one decision kind of is immediately reflected across the food chain into the rest of your portfolio. So those are my quick takeaway points here. Hopefully those were useful points to you. So now, last thing, of course, is it's a journey. No organization has pulled this off overnight. It's typically a few years of growing maturity and adoption of different processes and possibly systems behind the processes to help you along. It is a journey, but it's an important journey. I think it's a very big component of the asset management journey. And with that, I'm going to turn it over back to Prince because I'm sure there's a few questions coming my way.
Boudwijn, thank you very much. And just as backup in case my audio plays up, I've sent you most of the questions on your own chat. But for now, I will present the questions to you. The first one is around tools and systems, and I think the question being asked here is, we see the tool you're referring to here, and it looks like this is a different tool altogether to what the other asset condition assessment tools have shared. Is it correct then that this is really a different tool?
So that's a great question, and the answer is it doesn't need to be. It very much depends on where you are in your journey. In particular, what you see in some organizations now is the interest in what is often called the asset performance management tools. Or in some organizations, we're still at the level where they're using asset-specific condition monitoring systems as a way of determining what an asset class, a particular asset class might need. Like Doble has examples like that. EA Technologies has simple systems like that. All these particular systems are interconnected, of course. So yes, you're right in asking the question, in the sense that if you want to get to the point where you want to manage your portfolios of larger decisions, as I was showing on that little diagram with the three pillars there, that is typically a specific tool, like what Copperleaf would provide. It is fed though by the other tools, because of course condition assessments, yes, we need. Risk assessments, yes, we need. Actually, your maintenance plans, yes, we need, because those are all feed-in elements that we will use to make the broader decisions. Now, those information elements are not necessarily available, and yet organizations still have to make large decisions. So sometimes we'll turn it on its head, and rather than start bottom up, which is the approach that I talked about so far, using other tools, we'll actually start with a top-down approach, in which we will just ask engineers, project sponsors, to put in their best guess. Literally, if they don't have the data, just put in your best guess. Like, if we do this project, how much are you going to improve reliability? How much more productivity are we going to achieve? And of course, we might challenge you, but just put in your best guess, and we'll still have to manage that portfolio, because maybe the biggest problem is just the portfolio is constrained financially and resource-wise, and we need a better way of picking projects, even if those projects are not based on perfect data, which is just maybe not available. So it really depends. It's a bit of a chicken and egg discussion in a way. Both aspects are important. There is some overlap in some organizations. Condition assessment, for instance, is done within the asset investment planning system. In other organizations, it's done with the asset performance management system. It largely depends on what's available from a legacy point of view, and also what is the strongest, biggest burning platform, if you wish, within your organization.
Okay. All right. I've got a question from Marcelo. He's been joining us from Brazil consistently. He says that power utilities have a great variety of assets, from routers to high voltage equipment. How do you suggest that we put them in a common scale so that we can prioritize our investments? Everyone gets attention. Are there some recommended criteria?
Yes. So very much in the way that I was looking at my little car example, which of course was an oversimplification. But if you remember, just after the car example, we saw that screen where we had the strategic objectives of the company, and then the metrics that you could use to basically show that you're in line with those objectives. That is exactly what is happening in electrical utilities. So what you do is you start by looking at your different asset classes. You look at the risks that those asset classes might present to the organization. You look at how to quantify those risks. Now, a safety risk on a kind of high voltage tower might be different, of course, from a risk presented by a transformer, but you can quantify those, hopefully by monetizing them. Then your risk scales, and ideally your monetized risk scales, become the common currency on the risk mitigation side. In addition, of course, you might create extra goodness. Just again, maybe you're replacing your transformers with models that just make less noise, and the neighbors love it. So there is a soft benefit there, which you might want to quantify, that is noise level. How do you quantify that in dollars? Well, you can go and literally ask the neighbors, well, how much will you pay extra for us to put in a less noisy transformer? And actually, utilities do that. They will come up with willingness to pay analysis for the softer elements, so that again you can monetize them. And now you have a portfolio, a basket of different elements that you might be improving or fixing by doing particular investments, or by looking at the risk of your assets on a normalized scale, so that you can actually compare an investment in transmission towers to an investment in transformers to investment in reclosers, or what it happens to be. So that's typically your common scale. And the criteria is something where there's big libraries available that have been developed by other utilities, which you can use as a starting point. And generally speaking, you'll be 90% done right away. just by looking at the library and saying, yes, that applies to me, yes, that applies to me, this one maybe not. So it's a very quick way of getting there.
Wonderful, thank you. Imad here wants to know, somewhere you showed for evaluation your standard practice of using the value filter first and then constraints. And
Yes.
His question is, what are the potential impacts if I reverse these two, if I start with constraints first and then value later?
All right. So the problem with constraints is that they're kind of blind, right? Like, you know, this is literally like one of those one-way discussions where your CFO walks into the room and says, I'm cutting your budget by 20%, good luck. And he walks out of the room and he doesn't really care about how you do it. Constraints are blind in that sense. They don't understand what the needs are from your assets. So clearly, that's why we're trying to kind of combine the constraints, which are the obligations under which you are, with the value that you create, with the consequences of your decision. So in other words, it might be that at some point your constraints are such that you cannot honor all your obligations, in particular with regards to risk tolerance. If your budget gets cut by 50% all of a sudden, and you redo your calculations and you come to the conclusion that actually the optimization engine will come back to you and say, sorry, I cannot find a single answer to your problem. Like, I cannot build a portfolio of projects that actually honors all your risk tolerances, your financial constraints, your resource constraints. So you're going to have to give me something to play with. And that something to play with might be increasing your risk tolerance. So you might have to go back to management and say, look, I can cut my budget by 50%, but it actually does mean that as an organization, we're going to have to be more tolerant of risk, which might in turn actually force you to go back to the regulator and say, well, gentlemen or ladies and gentlemen, sorry, but you're going to have to give me a little bit more risk tolerance. In other words, you're going to have to kind of agree to the fact that we might have a few more outages, or we'll have the odd accident if you really want me to cut by 50%. So all this is interconnected, and that's really the way the discussion goes, right? Like, you as a technician, as a portfolio manager, will try your best to come up with an optimal portfolio that honors everything that's been thrown at you. If you can't, you have to bring it back on a totally rational basis, because you have rational data to play with now to say, look, I just cannot find an answer to the problem that you gave me. So give me some freedom, give me an extra 5% budget, or give me a bit more risk tolerance, or allow me to work overtime, or whatever it happens to be. But I need something so that I can find an answer for you.
Wonderful. And I suppose another approach could be to say, starting with value, whenever you apply the constraints, you can be sure that what you are left with is still probably biggest bang for buck.
Exactly.
Yes, you introduced the concept of total risk, and I'm very interested in this concept, and I see it's been asked as well here. This setting of total risk for the organization, how do you set? Do companies really set total risk? I mean, it sounds like a theoretical concept. How do you set total risk for an organization? I'm interested in that.
Yes, so I'm going to preface that by saying that there's certainly some debate around that, and not everybody is comfortable with the answers that are being put forward. But at the most simplistic level, the total risk, of course, is computed by monetizing every single one of your risks, or by putting them on a common scale. It has to be doesn't have to be necessarily monetized in Rand, but you have to put them on a common scale, so you can literally add up on that common scale what all your risks might be. Now, there is caveats to that, and the biggest caveat, of course, is especially if you're looking at a transmission network, you might well have a fair bit of redundancy in your network. So in other words, a straight sum of all your risks might actually be very misleading, and you might actually need a secondary game going off in the background, which is for a particular scenario where you have your risks calculated across your network, you might actually need to run a network simulation to actually tell me, under all these risks and therefore all these potential failures, what is the overall network risk, taking into consideration the redundancies that I have in my network. So that requires an extra layer of calculation, which actually quite a few transmission operators are getting to. They're getting to that level where, once I've computed the individual risks and have normalized the individual risk on a common scale, I will now run them through a network modeling so that I actually have a total view of what that actually means from a network point of view. If I now therefore pick a portfolio of interventions based on that, those interventions will of course improve my risk picture. Again, once I will therefore take all those different interventions, I will apply them to my network. That will result in a new risk profile. I will run my network simulation to actually see what the overall risk profile is based on that particular scenario, and I will use that to kind of compute the goodness or the value basically of that particular portfolio of investments.
Wonderful. Last question. These models that you've showed, we've spoken a lot about risk, and so on.
Yeah.
Tell me, on the reverse side, on the opportunities side, the question goes, could you use the same models to actually now mix opportunities and risks and actually come up with a total picture, or could you not?
You're absolutely right. That's exactly what you want to do. That's exactly what you want to do, because at the end of the day, you know, if you sit in the seat of the CEO, it doesn't matter where the project justification comes from. It all requires money and resources. So one way or the other, you're going to have to model what every single project is going to bring you. So a expansion project or a growth project or a technology project, whatever it happens to be, which is not directly related to existing assets, needs to be also kind of modeled in the sense of, you know, what value is it going to create for the organization. Actually, it's not only the value, it's also the cost, of course. So what we're starting to see now in some of the more advanced utilities is automatic costing models too. Because of course, in our business, a lot of the projects that we do are relatively repetitive. You know, especially on the distribution side, you know, you know quite well after a while what it costs to replace one pole.
Sure.
So you can actually build cost models which automatically will be applied to your business case justifications. So risk can be modeled, value creation can be modeled, and cost can be modeled.
Wonderful. Leslie, I think in a way that also answers your question. Thank you very much, Boudwijn. We really appreciate you taking the time off all the way from Vancouver. And I'm sure the audience got great value from that and all the other presentations before. What remains for me is to just thank not just you, but all the other guys that laid the groundwork before, for agreeing when Tebogo and I set up this program and what made sense and what would follow what and who we would approach. We were not sure it was going to pan out like this, but thank you to all the presenters, local and international, that have put their effort in. Just to remind our audience that all webinars are available on the SAIEE TV channel, and also if you go to the SAIEE website and go to events, past events, you'll be able to see a listing of them and active links there that take you to the recordings. But secondly, in time, we are going to be linking the PDFs of the PowerPoint presentations and the Q&As. So do access those sites with time, in time, to revise the content and apply it to yourself. Otherwise, thank you very much. Great evening. Good evening to everyone. Thank you.
Thank you very much.